Hello. Can you guys hear me? Yep. Okay. Seems to be working. Hello. Good afternoon. So since I haven't received any questions from partial fractions or binomial theorem, I'm gonna continue with the next chapter. Hey, Moses. I mean, reversality. Hello. Didn't intend to expose you there, but hello, hello. It's been a while. Anyway, let's continue. So let me just write that down here. Right. So we're gonna start with the addition formula. So the addition formula tells you that when you have sine A plus minus B, you would actually get sine cos plus minus cos sine. There we go. And then the cosine addition formula tells you that when you're adding up two things like this, you would get cos sine sine. The signs should be opposite, so it should be like that. There we go. So, for example, say I have sine sine 60 degrees. We can actually write this as sine. Do we use 60? What's another one we can use? Let's say sine 115 degrees. It's actually sine 45 degrees plus 60 degrees. Maybe just change this to 105. There we go. So using the sine addition formula, we can write this as sine 45 cos 60 plus cos 45 sine 60. And you get your calculator, put that in. You get root 2 over 2. Cos 60 is 1 over 2. Cos 45 is root 2 over 2. Sine 60 is 1 over 2, I think. No, it's root 3 over 2, okay. Root 3 over 2. And then you get your answer. And suppose you have, hey Elise, hello. Suppose you have sine 105. You can also write this as sine, say, 120 degrees minus 15, which means this is actually sine cos. But then you can see the sign here is negative, which means you have to follow negative. Let me make my pointer a bit bigger. One sec. Let's make this pointer bigger. So if this is positive, this one will be positive. If this is negative, this one will be negative. So since this is negative, you have to put a negative here. And so on. However, if we look at cos, you see that When cos is positive, you have to put a negative. When cos is negative, you have to put a positive. Okay. Now, the bigger question is, why exactly is the addition formula and the for these two sines and cosines the way it is? Why is it like that in the first place? Well, I'm going to show you that now. Suppose we have two right angle triangles. Let's say I have one right angle triangle like so. Let me see if I can draw it a bit bigger. So the proof for this is actually a geometrical proof. You have to put two right angle triangles and you stack them onto each other. Like this. So this angle, we're going to call that angle beta. This angle here, we call it angle alpha. And we're going to say that they are both right angle triangles. And this length here is going to be 1. Okay, so this entire length is 1. So let's say we call this y and we call this x. So using our trigonometric functions, we can see that x, hang on, let's say we do sine beta. Sine beta is going to be opposite over hypotenuse. So y is equals to sine beta. If we do cos beta, we are going to get adjacent over hypotenuse. Therefore, x is cos beta. So we can actually replace these guys here with cos beta and sine beta respectively. Cool. All right. Now, let me get rid of all that. What about these guys down here? What about these lengths? Okay, let's do the same thing. We're going to call this x and we're going to call this y. So if we take sine of alpha, opposite is going to be y, hypotenuse is going to be cos beta. So y is going to be sine beta, sine alpha cos beta. Doing the same thing for x, you can say cos alpha is going to be adjacent over hypotenuse. So x is equals to cos alpha cos beta. So now we can actually replace these guys here with cos alpha cos beta. Get rid of that. Replace this with sine alpha cos beta. Okay, we are kind of getting there. Let me just move this a little. Let's move it down here. Right, the next thing we're going to do is we're going to draw another triangle by drawing a straight line down like this. This is another right angle triangle. Right, and then you can see this triangle here actually has an angle of alpha plus beta. So let's say, all right. Whoa, Talkin. Hello. Thanks for the gift sub, Talkin. Very generous of you. Hello, hello. So let's say this this entire length, we're gonna call that y, and then this entire length, we're gonna call it x. And then what we're gonna do next is we're gonna do the same thing. We're gonna say sine of alpha plus beta is going to be opposite over hypotenuse. So opposite is going to be y, and it's going to be 1. So y is going to be equals to sine alpha plus beta. And then doing the same thing, let's say we're going to do cos alpha plus beta this time. We're going to get x over 1. So x is equals to cos alpha plus beta. There we go. So now we can actually replace these guys here with cos alpha plus beta. And you can replace this guy with sine alpha plus beta. Okay. Right, what else can we do? If we draw another line over here, you will see that we get another triangle right there. So many triangles. And then what we're going to do next is notice that this angle here, let's see if we can draw this angle. See this angle here? This angle here is actually 180 minus 90 minus beta. So that's actually going to be pi over 2 minus beta. So this angle is going to be the same because they are, I think the term is alternating angles, right? So this is going to be the same angle as this guy. And you can see there's another 90 degrees here, which means this angle right there has got to be alpha. So this boy here is alpha, which means this angle here must be 90 minus alpha because this is 90 degrees. So if this is 90 minus alpha and this is 90, this must be alpha. We can put another angle here. This must be alpha. So having done this thing, what else can we do? Well, you can see this from here to here. Let's call this y. And then from here to here, let's call it x. So if we take sine of alpha, we are going to get opposite, which is x, over the hypotenuse, which is sine beta. So x is actually sine alpha sine beta. And if we do the same thing, but we take cos, we're going to get cos alpha equals to y over sine beta. So y must be cos beta, cos alpha sine beta. Indeed, Tolkien is a mad lad. Raining money everywhere, Tolkien. So this guy's going to be y is cos alpha sine beta. Sine alpha sine beta. There we go. So now that we have labeled all these little things, we can finally do our proof. So if you look really carefully, you'll see that this guy plus this guy must be equals to this guy, right? This plus this must be equals to this. So let's write that down. Sine alpha sine beta plus cos alpha plus beta must be equals to cos alpha cos beta. Rearranging this, making cos alpha plus beta the subject, we get cos alpha cos beta minus sine alpha sine beta. And lo and behold, we get the first part of our second equation. Ta-da! At this point, you might be wondering, wait a minute, where do you get the, what if this is a minus instead? Would this be a plus then? How can I know that this is actually plus? Well, that has to do with the fact that cosine is actually an odd function, right? So remember that when you draw a cosine graph looks like this. And if you extrapolate the graph into the negative x-axis, you would get something like that. So it kind of looks like a mirror image. So what this tells you is that if I were to, you know what, let me just label this fx and we'll call this x. So if we take, this is positive x, let's say this is negative x. You can see that both of these things map to the same point. So fx is equals to negative, hang on, I messed up. Fx must be equals to f negative x for cos x. So this is a property of even functions. Okay, so what this tells you is that if I were to put cos alpha minus beta, it is actually the same as writing cos alpha plus negative beta. Okay, and we can use this guy here and write this as cos alpha cos negative beta minus sine alpha sine negative beta. And as you can see, fx is equals to f negative x. So this f negative beta is the same as cos beta. So this guy actually becomes cos alpha cos beta. Now, what about sine? Sine is what we call an odd function. So if we were to draw sine, what do we get? Sine looks like this. And if you extrapolate that into the negative x-axis, it kind of looks like that. So it kind of seems as though it has gone through some kind of rotation. The point is, if I take a x here, and then let's say this is negative x, you will see that they would map to different points on the y-axis. In fact, it will map to the opposite side, right? So this is, if this is fx, this is going to be f negative x. So fx is actually equals to negative f negative x for sine x, because it is an odd function. Therefore, instead of writing sine negative beta, I could actually write it like this. So sine negative beta is actually equals to negative sine beta. So I'm going to use that and I'm going to chuck that back in here, and that's going to give me negative sine beta sine alpha. So simplifying this, we get cos alpha cos beta plus sine alpha sine beta. And therefore, we have proved the second part of this equation. And as you can see, that's how you get the addition formula for cosine. Ta-da! Okay, what about the addition formula for sine? Well, we do the same thing, but instead of looking on the horizontal part of the triangle, we're going to look at a vertical part of the triangle. So if you look really closely, you'll see that this red guy here, cos alpha sine beta, is actually this big thing minus this small thing. See, this guy minus this guy gives us this guy, right? So let me just move that here a little. So we could say sine alpha plus beta is equals to, alternatively, you could say that this orange thing is actually this red thing plus this white thing. So that's equals to sine alpha cos beta plus cos alpha sine beta. Ta-da! So we've proven the first part. Now for the second part, we're going to write sine alpha minus beta, which is the same thing as writing sine alpha plus negative beta. And then we can use what we've already proven to write this out. So we're going to get sine alpha cos negative beta plus cos alpha sine negative beta. There we go. So negative beta, this is a cos, which is an even function. So we know that negative beta is actually the same as beta. So we can actually write this as sine alpha cos beta. Now, what about this guy? So in order to get rid of this negative, you can imagine just taking out the negative. So it becomes something like this. So that's going to give you negative cos alpha sine beta. And thus, we have proven the second part of the equation. So using the fact that sine and cosine are odd and even functions, and this little triangle here that we have stacked onto another triangle, we can prove these two things. Okay, there we go. Right, next up, what are we gonna do? We're gonna look at the different double angle formulas. Okay, actually, you know what? Maybe I'll do one more example on cosine because we haven't done an example for cosine. Just for completionist sake, we'll do one for cosine as well. So let's say we have cos, what shall we do? 30 degrees minus 15 degrees. So that's going to give you cos, and then we have to flip the sign, and then sine. Okay, quick example. Right. Next, let's look at some of the double angle formulas that you can encounter. I'll just move it down here, I guess. Let's move it down here. Actually, you know what? Let me just move this. Let me zoom out a bit. Zoom out a little. Take this guy. Lasso these. And I'm gonna move them over here. Plop. Okay. I'm gonna move down here. Zoom back in. Right. So using the the addition formula, we are gonna derive all the double angle formulas. So these ones are pretty important because they're gonna show up not just in this chapter, but in the later chapters like integration and differentiation. So, okay, you know what? Let me just get to it, then you see what I mean. So, suppose that we have A is equals to B in this case. So we have something like, let's say, sine A plus minus A. Or more specifically, let's say, and you know what? Maybe I do it this way instead. Let's say we have sine 2A. Okay? Sine 2A is actually sine A plus A. So using the sine addition formula, we can actually write this as sine cos sine. And then this is actually 2 sine A cos A. And that is your double angle formula for sine. And we're done. That's it. Okay, next up we have the double angle formula for cos. So this is actually just cos A plus A. That's going to give you, let's see, cos minus sine. So this is actually cos squared A minus sine squared A. So that's our double angle formula for cos. However, for cos, you can actually use the basic identity to generate two more double angle formulas, which are quite handy. So just to remind you what the basic identity is, sine squared A plus cos squared A is equals to 1. So using this, we can actually replace cos squared A with 1 minus sine squared A. Okay, so that's going to give me 1 minus 2 sine squared A. So that is our, well, I would say a second variant of the double angle formula. There. This one is very useful when it comes to integrating powers of cos or sine later in integration, which is something that we'll touch on much later. And then next up we have, if we replace sine with 1 minus cos squared a, we're going to get, so from here we get 1 minus cos squared a, then cos squared a minus cos squared a. Wait a minute. Did I mess up? Oh no, I didn't mess up. Okay. There we go. So we're going to put that in here. Hello, Knife Light. I would appreciate it if you don't share links without asking first, because I would not want people to click on random things, and they might potentially be what should I say this? How should I say this? There might potentially be malevolent links, so please don't share links unless you've asked beforehand. Okay, next up, what do we have? I don't know, and I don't think I want to find out. Because there's a lot of bots on Twitch, so they randomly send out links. Some of them are harmful, so I usually just straight out time out people who post links without asking for permission first. Can't be too safe. Okay, next up, what else do we have? So we have found the double angle formula for these two. Oh wait, there's also the addition formula for tangent. Yeah, there's a lot of bots on Twitch. I've actually banned a lot of them already, but they keep making new accounts and keep coming back. I'm not really sure what's the point of having a bot on Twitch, to be honest, but it is what it is. So let's find the addition formula for tangent. So let's say we have tangent a plus minus b. What is that going to give us? Well, let's see. Let me just move that over here. So some extra room. I'm going to write here. So we know that tangent is sine over cos, right? So we can actually say tangent a plus minus b is equals to sine a plus minus b over cos a plus minus b. Bots got you banned for sending illegal links in chat. Oh, you mean like auto mods? Yeah, I don't use auto mod because sometimes they might randomly ban things that don't need to be banned. I can imagine why people use them though, especially for larger streamers, because they have too much to handle. Then again, that's why you have mods moderating the stream. Human mods, that is. So using this, we can just put in our addition formula. We have sine a cos b plus minus cos a sine b divided by cos a cos b minus plus sine a sine b. There we go. Now, what we can do here is we can divide everything by cos a cos b. Okay, so divide by cos A cos B. By the way, this derivation is quite important. I would highly recommend that you remember how to do this, because there are certain questions where they kind of expect you to do this. Well, not directly like this, but there are certain kinds of questions that involve doing this. So anyway, if I divide everything by cos A cos B, I'm going to get tangent A here, tangent B here, and then this guy is going to give me 1 minus plus tangent A, tangent B. And there you go. This is the addition formula for tangent. Oh yeah. Okay. What about the double angle formula for tangent? Well, you can actually derive that using the tangent addition formula. So let's say we write tangent 2a. That is the same as writing tangent a plus a. Right? So using the tangent addition formula, we get tangent a plus tangent a over 1 minus tangent a tangent a. So simplifying this, we get 2 tangent a over 1 minus tangent squared a. So there you go. Tangent double angle formula. The one that you would be using most when it comes to the double angle formula would be this one, and maybe this one. Usually you'll use these three. So the way I remember how to differentiate between this one and this one is, because you can see they are very similar, so it's very easy to get confused between the two. So the way I remember this is by thinking about the alphabetical order of the first letter. So C comes before S, so that's why 2 cos squared A is before the 1, but then sine squared A comes after C, so it's behind, right? Like, A, B, C, D, E, F, G, C comes first, and then S comes later. That's how I remember it. So there you go. In any case, you can always refer to your data booklet. I believe they've actually given you the formula for all of these. So let me just bring that out and show you. Yep, over here. There. Trigonometry. And you're also given the basic identity right here. And then the two other identities. And then the addition formula, sine and cos. Tangent is given as well. The double angle formula for sine, double angle formula for cos, double angle formula for tangent. There. So you don't actually have to remember it, but it helps if you know by heart what these identities are, because a lot of the questions rely on you recognizing that, oh, this is an identity and I can use this to replace this to get this. So a lot of this comes down to practicing. You have to do a lot of practice to really drill this into your head. Anyway, yeah, that's that. Okay, let's see. Let's do some questions. Okay, let's do one question right here. So let's say they want you to solve cos 60 plus theta equals to sine theta. So if you look at this guy here on the left, this actually, you can use the addition formula for cos to expand this. So cos would give you cos, cosine, sine. So cos minus sine equals to sine theta. And then we can actually use our calculator to get rid of the cos 60, which is a half. Sine 60 is root 3 over 2. So this is going to be cos theta over 2 minus root 3 over 2 times sine theta equals to sine theta. Okay, and then what you can do next is put all these sine thetas together. So you have cos theta over 2. This guy is going to be root 3 over 2 sine theta plus sine theta. So root 3 over 2 plus 1. Or you can think of it as factorizing up the sine theta is going to give you sine theta and then root 3 over 2 plus 1. And then we're going to move this cos over here. So we get sine theta over cos. And we're going to move this entire bracket to the left. So we're going to get, let's see, this is 1 over 2. So this would be 1 over 2 times root 3 over 2 plus 1. There we go. So we get tangent theta equals to this thing, whatever that is. So root 3 over 2 plus 1 times 2. 1 divided by that gives me 2 minus root 3. So theta is equals to arctangent of 2 minus root 3. Okay, so arctangent of that is going to give me 15 degrees. So remember, this is your principal angle. So now we have to look at the cast diagram. And this is a positive tangent, which means it's going to be in the first and third quadrant. So therefore, theta is going to be 15 degrees, and then 180 plus 15, which is 195 degrees. Assuming, of course, that the domain for your angle is between 0 and 360, which we will assume for the sake of this question that it is. Okay, there we go. Right. Maybe I'll do one more question. I'll do one more question, and then I will let you carry on with the rest. So let's say we do... Let's pick a question from the past paper. Yep. This one seems worth doing. Let's try this one. Take a snapshot. We'll take this one here. And then I'm gonna move this over here. Okay, question 3. Showing all necessary workings, solve the equation, blah, 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 blah. So if you look at this, you see that this is nothing like the addition formulas that I've shown you, right? Because one is cotangent, the other one is also cotangent. So what are you supposed to do here? Well, you can actually write this as 1 over tangent theta. So first, change everything to tangent. This one is actually 1 over tangent theta plus 45 degrees equals to 2. Now, this looks like something you can expand because we know what the addition formula for tangent is, right? So let's expand that. So that will give me... So what is the addition formula for tangent again? Let me think. It's tangent plus tangent 45 divided by 1 minus tangent theta tangent 45 equals to 2. And then what we can do next is we're gonna flip it so it's a bit less messy. And let's tangent 45, we can put it into a calculator. So tangent 45 is 1. Okay, so we get tangent theta plus 1 equals to 2. And now we can multiply everything by, say, should we actually do that? Let me think. Yeah, okay. So we can now multiply everything by tangent theta and then tangent theta plus 1. Okay, so basically this whole thing we're going to multiply by this amount to get rid of the denominators. So now we're going to end up with tangent theta plus 1 plus 1 minus tangent theta equals to 2 tangent theta plus 1. Okay, expanding this guy, we get tangent theta minus tangent squared theta equals to tangent squared theta plus 2 tangent theta. So now we can put everything on one side. That's going to give me 3 tangent squared theta, and then plus minus, so plus 2 minus 2, tangent theta disappears, and then we have minus 1. Therefore, tangent squared theta is equals to 1 over 3, which means tangent theta is equals to plus minus 1 over square root of 3. So first, let's find the principal angle by just taking the positive root. So 1 over square root of 3, and put arctangent, is going to give us 30 degrees. So this is our principal angle. And we're going to look at our cast diagram. Now, because it is both positive and negative, we have to take all 4 quadrants. But then we also have to look at our domain. If you look at our domain, it is actually from 0 to 180, which means we only take the first 2 quadrants. So therefore, the angle is going to be 30, and then 180 minus 30 is 150. And that's how you solve this question. Okay, that's pretty much it, really. So there's actually a bit more to this chapter, but I think I want to stop here. I don't want to overload you with too much information. So we will continue with the second part of the chapter another time. So for now, this is all you. Yeah, I'll leave you with this, and then I'll send you the exercise on the textbook for those of you who don't have a copy of the textbook. And then you can try some of these questions. So the homework for today is going to be exercise 3B. Nom 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 nom. Yep, essentially just do the whole thing, because you should be able to do all of them. Nom 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 nom. Okay. Oh, there's actually something I forgot to mention. I'm not sure whether I've mentioned this in AS, but I think I might have. But just to be sure that I don't miss anything out, let me just mention it here. So remember our original identity cos squared x plus sine squared x equals to 1. If I divide everything by sine squared x, I'm going to get 1 plus... you know what? Let me just write it out. If I divide everything by sine squared x, I'm going to get something like this. So that's going to give me 1. This one is going to give me cotangent squared x, squared theta, sorry. This is going to give me cosecant squared theta. So that's our second identity. However, if I choose to divide everything by... You guys really like that, don't you? Nom 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 nom. So if I divide everything by cos squared theta instead, I'm going to get tangent squared theta plus 1 equals to 1 divided by cos squared theta, which is secant squared theta. Hey. There we go. So that's how you get the 2 identities. But in any case, if you don't remember how to do this, you can always refer to your data booklet, because it's all there. Okay. I think we'll stop here for today. Again, you can try exercise 3B. I'll send the exercise for those of you without the textbook soon. And see you guys tomorrow. Yep. Bye-bye.